Hello, Stella.
Logic.
Hello, Alan. Hello, Mia. Hello, Calvin. Do you think the homework was hard? Do you think it was easy, medium, or
It was easy.
good? We'll wait about a few more minutes. More people might join.
It's 4 o'clock.
Did you do anything fun this week that you want to share? Maybe about math or anything else? Yes, Yo-Yo?
I got a haircut.
Nice. I can see.
Oh, it didn't happen, but I heard my brother say that we're going to go somewhere, but I don't know where it is. But I bet it will be exciting.
Nice. And I think we can start. Alicia?
Okay, so hello everyone. Welcome back to Math Kangaroo Preparation Lesson 6. In this lesson, we will learn about logic. So now I'll hand it over to Felix to present.
So does anyone know what is logic? Can anyone try to explain? What do you think is logic? Yes, Chill?
Well, I guess logic is about the traffic jam. I think is it doing math on a traffic jam.
Okay. So logic is using a mathematical thinking to find a solution to a mystery. And it often seems like being a detective. So when I do logic, I often think like I'm a detective trying to figure out a big mystery. So this is the first example. Finding a toy and its logic. Anne put 6 toys in one shelf with 6 cubbies, like this. When you look at the shelf, you see that this teddy bear is between the blue bear and the chicken. And this blue bear is right above the train. And the princess is to the left of the colorful train and to the right of this train. Which toy is in the gray cubby? I'm gonna first give some time so that others can have the chance. Yes, that is a tricky part. So you're super close, but the third sentence contains a trick. If you read the third sentence very carefully, you'll see that the princess is to the left of this train and to the right of this. And I think I heard that the princess is in the middle on the bottom. Right, Cho? Did you say that?
Yeah.
And now let's look at this train. This train has to be on the left or the right. And do you think it's on the left or the right?
I think it's on the left and it's the middle.
No, this train. This train. Left, right, or middle?
Middle.
Remember, the princess is in the middle because it's to the left of this and to the right of this, so it's in the middle, like a hamburger. So where is this one? Where's that? Is it to the left of the princess or to the right? Yes, Phoebe?
I think it's the trains to the left of the princess because it said the princess is to the left of the wagonist train.
Okay, the princess is in the middle. We know that. So is the train left or right, and is the wagon left or right?
The train is to the left of it.
The train is to the left, right? And this is to the right, right? And also, by the way, does everyone know why these three are on the bottom? But if you look at this sentence, it says this bear is right above the train. And if it means that this is right above the train, that means that all of these three have to be on the bottom, right? Because if all of these are on the top, then this can't be right above. So if you see these three, if these three are on the top, then this can't be above, or else it's going to be floating up here. You understand? Yeah, so these three have to be on the bottom. So there's going to be something on top of it. So So yeah, so that's on the bottom. And so Phoebe, you think that this is here, right? You're absolutely correct. And now what made this problem so confusing is that the princess is here. And the train is on the right of this. So it's not this is on the right of this. This is on the right of this. So basically the princess or this train has to be here because the princess is on the right of it. So if you're the train and you look right, you see the princess. But if the train was here, and then if you're the train and you look left, you see the princess. But it says to the right. Does everyone understand why the train is here?
Then I took another guess. So now I think the gray square is the chicken.
Good. And remember, it's never a guess. You always have to be firm. So yeah. So if the train is on the left, then the wagon has to be on the top. And remember that the blue bear is here. The blue bear. The teddy bear is up here. And the chicken is right there. So does everyone understand why it's the chicken?
I do.
Good. So everyone understands. The second one. So Sia hides a smiley in some of the cells of the table. In some of the other cells, she wrote the number of smileys in the neighboring cells, as shown in the picture. Two cells are neighboring if they share a common side or a common corner. How many smileys did she hide? I'll give you a few minutes to figure this one out. I'll just highlight some keywords here.
I don't understand.
Oh, so Charlie, you don't understand the problem.
Yeah, what is a smiley?
That's a smiley. But the smileys are on the blues, but it's only on some of the blues. You don't know, it's not on all of them. It's only on some of the blues. You have to figure out how many smileys you put. Like, does this one have a smiley? Does this one have a smiley? Does this one have a smiley? You have to figure that out. That's the.
How do we know one had a smiley?
Okay, so I'll explain this to everyone. You see that there's a number 3 here, right? That means in the neighboring cells, so that means there are 3 smileys next to it, right? If there's a number 1, that means there's 1 smiley next to it. You see, this is a 2. That means there's 2 smileys next to it. Do you understand?
I think I have it.
Chuck, can you please?
I think the answer is 5.
It's 5, right? Now, how did you get the answer?
Can I annotate?
Sure.
They said in the neighboring cells means next to them, and so there should be for the 3, there should be one here, here, and here because they're in the neighboring cells.
Mhm.
And for the other 3, we can put one there to make that have 3 next to it. And for the 2, for the 1, we could put one here. And for the 2, if we add one more for it, it will become 3
Good job.
because it already has 2 next to it. That one has 2 next to it too.
So good job, Miana. So exactly what she said. Okay. So I'm just gonna explain it again. So the first clue you can see is the number 3 here. So let me ask someone, how many smileys must the cell have that's next to it?
3.
Good. So there must be 3. So the only way to fit 3 smileys is here, here, and here, right? Those are the only 3 ways to fit smileys in the neighboring cells. And neighboring means that this way and diagonally. If these 2 are neighboring cells and these 2 are neighboring cells. So now we know that the 2 can only have 2 smileys next to it. But the 2 already has 2 smileys next to it. So these 2 have to be no smileys. You understand why these have to be no smileys? The X, where the X is? Or the
I-
camera smileys? It's okay if you don't know. Good strategy. Exactly, good strategy. So that's why I'm starting with the two threes, the two threes, because those threes are the biggest one. But the left one is easier to start with because they only have three neighboring cells. So since these are neighboring cells, these two have to be X. Does everyone understand why these have to be X?
I know why they're X's.
Okay, so can you explain it again then?
Because the first two, there already is two smileys next to it, and the two can only have two smileys next to it. So if you add one smiley there, then there will be three smileys, like number two, and the other two, it already has one smiley.
So yeah, you're answered. Because the two can only have two next to it, right? So
Mhm.
can't have the other two, because then it'll be four, and the two will not be four. And now the next clue is looking at the three. We know that the three has only have two right here, only two. How can we get another one? Now there's two other places for the smiley, here and here. Which one do you think is correct? Is it the top one or the bottom one? No? Do you think is it here or is it here?
It has to be the top because it has to be next to the three to finish the three.
But remember, it can also be on the bottom because diagonal also counts.
But if it's on the bottom, the two, it can't be because the two would be three.
Exactly. The two will have three, and we know that that's not possible. Now let's look at this. So this is an X. Nope. And now this has to be an X too, because all of these have to be X. Do you know why all of these have to be X?
Because
Yep.
they're next to the two.
Exactly. They're next to the two, and the two already has two, so it can't have another. But let's look at the last one. The one needs one smiley. And where can the smiley be?
Smiley can be in a square that has no X in it.
Exactly, right here. So let's count. We have 1, 2, 3, 4, and 5. So the answer is B.
Oh, now I get it because they can share one square.
Yeah, they can share. Like the 2 is also here, the 3 is also here. They can share one.
Okay.
You understand now, Cha?
Yes.
So the next one. Finding the true statement. It's also logic. Sylvia, Tara, Una, and Wanda went out for dessert. They stood in line, one after another. Each one of them ordered one of the following desserts: ice cream, waffle, bun, and cake. And each one ordered a different item. We know that, number one, the first girl did not buy the ice cream or the waffle. Una was not last in line, and she bought the cake. Sylvia, who was standing behind Tara and in front of Una, did not buy the waffle. Which of the following is true? Wanda was first in line, Tara bought the ice cream, Wanda bought the waffle, Una was second in line, Sylvia bought the bun. I'll give you a few minutes to figure it out.
Well, okay. It said the first reason is that the first girl did not buy the ice cream or the waffle. So Wanda could be the first, but we don't know. Anna was not last in line, and she bought the cake. Sylvia, who was standing behind Tara and in front of Una, did not buy the waffle. So first, we know that Una was not last in line, and Sylvia, who was standing behind Tara and in front of Una. So we beside Una and Una, Tara, and Sylvia, there's only Wanda. So Wanda can be last in line because it says Una was not last in line And it also said that Savaya was in front of Una and Tara was in front of Savaya. So then Una's last in line. So we know Wanda is not first in line. So I crossed out that one. And it also said, and the first girl did not buy the ice cream or the waffle. So Tara did not buy the ice cream or the waffle.
So
And said Una bought the cake, so no one else should buy the cake. And Savaya, who was standing behind Tara, did not buy the waffle.
So, Miana, you said it correctly. So what I like to do in these types is I'm gonna make sort of a line. And let's see, this is the buying place. So now let's look at the second one. Una was not last in line, and she bought the cake. Let's order the U right here. We don't know if it's the second or third, or first. But it can't be last. That's all we know. Now, let's look at the third one. Solvaya, who was standing behind Tara and in front of Una, did not buy the waffle. So we know Solvaya stood in front of Una, but behind Tara. So is Tara first or is Tara second? So remember, if Wanda is first, then that means Una was last, but Una was not last in line. So Wanda has to be last. So this is the order. We know the order now. Now we can start eliminating stuff. Those two are obviously not right, because we're starting eliminating. Now the first one is the first girl did not. Oh, also under Una we can write the cake, because we can remember that's a cake. Now the first girl did not buy the ice cream or the waffle. So we know that the first girl did not buy ice or waffle. So if Tara didn't buy ice cream and waffle, what could Tara buy? Or cake. Tara can't buy cake either because Una bought the cake. Yo-Yo, you can go.
Bun?
Exactly. So Tara has to buy the bun. And now, let's see, Sylvia, who was standing behind Tara and in front of Una, did not buy the waffle. So what could have Sylvia bought? Remember, Tara bought the bun. Because Tara did not buy ice cream or waffle or the cake. So Tara bought the bun. But what does Sylvia buy? So you can't buy the bun or the cake or the waffle. What could Sylvia buy? Exactly. Sylvia bought the ice cream. So now, what could Wanda buy?
She could buy the waffle.
Exactly. Wanda could buy the waffle. So now, Tara bought the ice cream. Tara bought the bun. Sylvia bought the ice cream. So that's not right. And Wanda bought the waffle. That is correct. Does everyone understand this problem? Do you have any sort of questions? Finding the true statement. Logic. 7 children are standing in a circle. No 2 boys are standing next to each other. No 3 girls are standing next to each other. Which of the statements below about the number of girls standing in the circle is true? Imagining is a good thing, but sometimes you need strategy. How to imagine? Yes, Yo-Yo?
I think it's E.
E. 5 is the only possible answer. Now let's just take a look at 5 right away. Now the only possible way to get 5 is if we put, let's write a girl. Boy, girl. There's a girl here. And then a girl. And then a boy. And then a girl. That's 7 people. But it says no 3 girls are standing next to each other. And these are 3 girls, right? So 5 is definitely not possible. So thank you for suggesting that though. So D and E are already eliminated. And for giving that star, we can start looking at number 3. Now, 3 is a bit little, but is that possible? But if you have 3 girls, that means you must have 4 boys. And no matter how you arrange the boys, like this, there will always be 2 boys. So 3 is not possible. Okay, so E is not possible, D is not possible, A is not possible, and B is not possible. Then what's possible?
C.
Good job. So C's the only one left. And to make sure, you can just test. Say girl, girl, boy, girl. Wait, girl. So it's boy, girl, boy, girl, boy, girl, girl. So that's 4 girls, and that's the only possible way to get the girls in. Does everyone understand?
Okay, I got the line. I was like, boy, girl, girl, boy, girl.
Yeah, so 4 is the only possible answer. Yeah, but you got another way to get 4 girls. But 4 girls is the only possible way. And also, since there's 4 girls, if you say there's 4 girls, that means there's going to be 3 boys. And if there's 3 girls, then there has to be 4 boys, and that's not possible. 5 girls and 2 boys, that's also not possible. Only 4 and 3 seem to match. Does anyone understand this problem? Finding the order. It's also logic. This one's a bit easy. 4 friends, Masha, Sasha, Dasha, Pasha, are sitting on a bench. At first, Masha swapped places with Dasha. Then, Dasha swapped places with Pasha. After this, the 4 friends are sitting from left to right in this order: Masha, Sasha, Dasha, Pasha. In what order, from left to right, were they sitting to begin with?
Dasha.
I think, Chow, you hit the right answer, but remember, this is the ending position. This is the ending position, but they're saying the starting position. Okay,
I got
Chow, I'll give other people a bit of more time. Okay, Chow, you can go.
First I was like, if Dasha swap places with Pasha, then Pasha will be second and Dasha will be last. But then Masha swapped places with Dasha, so Masha should be at the end. And then I will look like which one had Masha at the end, and then I will like C, because C is the only one that does it.
So we can start with the ending position. Pasha. So we know that at the end, Dasha swapped places with Pasha. That's the last move. So let's sort of rewind. So let's just make them switch with each other. And if they switch with each other, it's gonna be Masha, Sasha, Pasha, and Dasha. So that's the order that will be when they swapped once. But now we gotta rewind again. And the first move they did was Masha swap places with Dasha. So let's just switch them. And so it's gonna be D, Dasha, Sasha, Pasha, and Masha. Can you tell me which one is Dasha, not Dasha, Sasha, Pasha, Masha?
C.
Good job. C. Dasha, Sasha, Pasha, Masha. Does everyone understand this problem? It's not very hard. The next one. Karen wants to place 5 bowls on a table so that they're ordered according to their weight. She has already placed the bowls Q, R, S, and T in order, where Q is the lightest and T is the heaviest. Where does she have to place bowl Z? Yo-Yo, do you have an idea?
I think it's to the right. A C.
Between bowls R and S. Also very close. You both are very, very close.
To the right of Volti.
Think again. So I can explain now both of you are very, very close. So let's take a look at Q and R. Let's just look at those two. We see that the only difference is that these have triangles and these are circles, right? That's the only difference. Therefore, this means that a triangle is lighter than a circle, right? We can make that because this is more heavier than this. So now we know that triangles are lighter. You can immediately look at, and squares are the heaviest because there's two. Once I see this, we see that there's a triangle and a circle. So where should we put the Z? Yes, Phoebe? Is it
I think it's in between Q and R.
exactly? So it's between Q and R. And the reason is because a triangle is smaller than a circle. And this is sort of like replacing the circle with a triangle. So this is definitely lighter than this. But for this one, it's like replacing this triangle with a circle. And circles are heavier. So it has to be in the middle, and it's B. Like I said, Chow, you're very close. It's not here. And you're also very close. Yo, it's not here. It's right here. Does everyone understand? Do you understand, Chow? This one has a light, a medium, and a heavy. But this one has two mediums and a heavy. So Z is like replacing the medium with a light. So isn't this going to be lighter?
That which one equals how light?
This is going to be lighter, right?
But how do you get which one equals light, which one equals medium, which one equals
Light. Remember? Because the triangles are lighter than the circle, but the circle's not as light as the.
get that?
Oh, you didn't hear? Because
But
triangles are lighter than circles because of Q and R, and this has two squares, so that's heavier. So squares are the heaviest. Do you understand, Chia?
okay. Okay.
Okay. So, Andrew, Stefan, Robert, and Marco meet each other at a concert in Zagreb. They come from different cities: Paris, Dubrovnik, Rome, and Berlin. Andrew and a friend from Berlin arrives first in Zagreb. None of the two have been to Paris or Rome. Robert is not from Berlin, but he arrives with his friend from Paris. Marco and his friend from Paris enjoyed the concert very much. From which city does Marco come? So, like I said, I like making a graph. So let's write. Wait, so let's write. There's Andrew. There's Stefan. There's Robert. And there's Marco. I'm gonna write the name of the city under them. Now let's look at the first clue. Andrew and his friend from Berlin. So that means Andrew cannot be from Berlin. Arrived first in Zagreb. Neither of the two have been to Paris or Rome. So that means Andrew is not in Berlin or Paris or Rome. Then where can Andrew be? Does anyone know? Where can Andrew be? If he's not in Berlin or Paris or Rome. Yes, Joe?
Dubrovnik.
Exactly. Let's just call it D. It's from D. So Andrew is from D. Okay, so someone's from Berlin. Now we know that Robert is not from Berlin, but he arrived with his friend from Paris. So Robert is not in Berlin or Paris or Dubrovnik. So where can Robert be from? Yes, Yo-Yo?
Rome.
Rome.
Exactly. So R's, two R's. Now Marco and his friend from Paris enjoyed the concert very much. So Marco's not from Paris or Dubrovnik or Rome. So where can Marco be from? Yes, Yo?
Berlin.
Exactly. He's from Berlin. Now where can Stefan be from? So he's not in Berlin, and he's not in Dubrovnik, and he's not in Rome. Where can he be from? Does anyone know? Where can he be if he's not in Dubrovnik? Yes, Bella? You raise your hand. Or Rome or Berlin.
He is from Paris.
Exactly.
Well, I didn't hear the country name wrong because it says on the bottom.
So from which city did Marco come from? Is it Paris? Oh, this is a typo. Is Is it Dubrovnik, Berlin, or Zagreb? Okay, so where is Marco from? Is it Paris, Rome, Dubrovnik, Berlin, or Zagreb? We can look at here.
Berlin.
Good job, whoever shouted it out. So it's a D, Berlin.
It was me.
Okay. Does everyone understand this? It's okay if you don't. I'm gonna go to Kahoot now, so.
Good job, Mianna.
Good job. Thank you for coming. Next week's class is possibility.